Hello, welcome back. This is the tutorial for C++ two-dimensional array and vectors. So we're going to continue using the workspace we created for the previous four tutorials. So my current screen is when I first log into my virtual machine. So if you are using virtual machine, you should be looking at something similar. And well, there might be some other more text, right? And if you have a online IDE, all you have to do probably you just need to create the C++ files, and then you will be good. All right. So first of all, let's look at all the folders we have currently. So remember, I just logged into my virtual machine. I haven't done anything, right? So when we look at all our folders, well, now we see we have three folders. We have CPSC 271, and then we have the two other. So last tutorial, all my code are in CPSC 271. So I'm going to go ahead and go into that folder. So cd CPSC 271, all uppercase. So now I'm in the folder. I'm going to do emacs array.cpp. So that will open up the Emacs text editor, and it will create a array.cpp on the virtual machine. As you can see, I already have something in there, so let me delete all of this and start over. So for this example, we're going to need the IO stream because we need the cout, cin, the console input, output. Probably not console input, but we need the console output. I'm not sure if we need string. Let me go ahead and do that as well. And then after that, using namespace space std, need that, and then let's create a main method like this. All right. So the most basic form of two-dimensional array in C++ is like this. So int a33 equals to curly brackets, and curly brackets again, 1, 2, 3, comma, 4, 5, 6, comma, curly bracket, 7, 8, 9, close curly bracket, semicolon. So that's how you create sort of like a hard-coded two-dimensional array. Of course, if you don't want to hard code it, you can always do this, right? Do this like for int I equals 0, I smaller than 3, I plus plus, and blah, 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 and then fill in each cell, right? So if you don't want to hard code it, you can do it that way. The other thing, whenever you are dealing with array in C++, if you are not using the array class, like we talked about in part 2 of the tutorial, you probably want to carry around the sides with you. Because in C++, array doesn't have like the dot length as in Java. Basically, it's a little bit complex to look at the sides of the array. So we're going to go ahead and carry the sides. So let's do row. Let's separate the two, right? Int row in column equal to 3, right? Because what if we want to do like 3 or 4, right? 3 rows, 4 columns. You never know. So let's separate those. And basically, you can access your array like this for int I equals 0, I smaller than a row I plus plus, for int j equals 0, j smaller than column, j plus plus, cout a row column. I need to put one more. Hold on. It needs to be cout double smaller than sign, a square bracket row square bracket column double smaller than sign, and then let's put a comma in there, and then we close the for loop, and now we do cout and line and L, and then we close the outer for loop. So this will just print all the content in our array A. So for now, let's save this. So again, if you want to save it, you want to hold down Control right? Hold down Control the whole time, and then you want to press X, S. Again, there's Control. You want to hold down Control and then press X, and then press S. If you want to quit Emacs, you want to again hold down Control, and then click X, and then C. So it will quit. So let's compile this code. Let's do G++ array.cpp and then -o array.exe. Right, nothing's wrong. We can look at ls list directory. You can see array.exe is in there. So let's run it. /array.exe. So it prints out all of the values, which are all ones. That is kind of strange. Did I make something mess up somewhere? Oh yeah, shouldn't be row column, should be ing. Right. So let's recompile. We run this. Yeah, now it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so the mistake earlier was because we're looping through the for loop, right? And then we have ij here looping, but instead of ij, I put row and column in there. So that was the mistake, right? Just on a side note, in Java, this is index out of bounds, right? Think about it. You have size 3, so your index goes 0, 1, 2. So if row is 3, then it's the fourth element. So in Java, this should give index out of bound exception. Look at what C++ does. C++ doesn't care. Gives you a bunch of ones. So in C++, you got to be very careful because sometimes even though your array is out of bounds, the behavior of C++ is unpredictable. Right? Sometimes it stops, sometimes it crashes, sometimes it doesn't. Like here, it should be crashing, but it's not. So with C++, you have to be extra careful with how your index are going. All right, so this is the easiest form of two-dimensional array, right? Super simple. Now, what if I want to create a pointer for two-dimensional array? Now that is a bit tricky, right? So if you remember what we did with two-dimensional array, let's bring out Paint. If you remember what we did in two-dimensional array, this is what we did. This is what we say the two-dimensional array is. So instead of looking at two-dimensional array as a bunch of cells like this, right? Like that's a two-dimensional array, right? You have like 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, right? Instead of looking at them as separate elements, the other way to look at two-dimensional array is it's a array of arrays, right? You have 3 rows, and then each row is a array that contains 3 elements, like this, right? This is the other way of looking at two-dimensional array. So that's exactly what we are going to do. Basically, each one of these will be a, oh my gosh, whatever. Each one of these will be a array itself. So we can have a pointer pointing to each one of these arrays like this, right? So each row will be a pointer that points to a array object. So then what is the overall? What is the overall array like this, right? What is that? Well, it's a pointer. It's an array of pointers, right? This is an array of pointers. So if we want to put a pointer to the array of pointers, we do it like that. This is a pointer to a bunch of pointers. So this is how you code it out. This is how you code it out. So you do int pointer to pointers a equals to new int pointers 3, like that. So what this is saying is I have a pointer to an array of pointers, right? So it kind of looks confusing, but it breaks down like this. It breaks down like that. So basically, you have a pointer to a pointer, right? That's what basically this is, right? This is pointer to a pointer because we have 3 pointers here, and then we have array of that. So we have a pointer to the pointer, right? So it's like this points to, this is a pointer, which is star. That points to a pointer. So it's a star pointing to a star. That's why we have 2 stars there, right? That's why we have the 2 stars up there, right? So this is the 2 star. This is why we have the 2 star. Now back here, we have 3 of integer pointers. So 3 represent rows. We have 3 rows of integer pointers. Now you might wonder, okay, well then how do I express that the each pointer of each row, right? We have 3 pointers, 3 rows. Each pointer of each row is also an array. Well, this is how you express that. 4, well, let me put the int row equals to 3, int column, let's do 4, like that. You do it like this, int I equals 0, I smaller than row, I plus plus, and then you do a I equals to new int column, like that. Basically, for each row, you get a integer array pointer. So that's how you initialize the 2-dimensional array with pointers. So let me just rearrange this a little bit so that it looks prettier, right? Let's do it like this. There we go. So we have the row column number in the front, and then we create the 2-dimensional array pointers, and then for each row. So here we are initializing the rows. Well, no. Yeah, we're initializing the rows. We say, okay, we have 3 rows. We have 3 rows, right? 3 rows of integer pointers. And each one of those integer pointer points to a array of 4 columns. So that's the picture of array as 2-dimensional array as array of arrays, right? And then once we do this, you access the 2-dimensional array like anything else. Aij equals to, let's say I. It looks like that. And then we can print it out. We're going to see out A, I, J, comma, and then see out and line. So basically you access it exactly like the same. So let's compile this. I have oh yeah, I need to remove the parentheses. Yeah, so the parentheses, so that was just for demonstration, but the parentheses shouldn't be there. It should just look like this. There we go. So 0, 0, 0, 0, 1, 1, 1, 2, 2, 2, right? Because each row we just print the I number, right? Each row we just print the row number. We put the row number in there. So the mistake before was I'm really not supposed to put parentheses there. So this is the syntax. This is the syntax for basically array of arrays, right? So it can be kind of confusing because you have two stars. Obviously, what if you want to do three-dimensional arrays? What does it look like? Well, you just add more stars, right? You do int 33b equal to new int 2, 3, right? And then do for int I equal to 0, I smaller than 3, I plus plus. And then for each b equals to new int star 3. So it's kind of like a cube, right? We have three two-dimensional arrays. So for each two-dimensional array, we have three arrays, one-dimensional arrays. And then you do b I j equals new int 3, like that, right? So we have a three of two-dimensional arrays, and then for each two-dimensional array, like this, so for each one of those two-dimensional array, we have the one-dimensional array, right? Does that make sense? So basically we have, okay, so three two-dimensional arrays here. And then BI represent the two-dimensional array. So each two-dimensional array, it's three one-dimensional array, right? So each BI, it's a three one-dimensional array. So here we're looking at each BI, and then each BI J, right? So basically, each BI is a three one-dimensional array. So then we go into those three one-dimensional array by using J, right? So BI is a three one-dimensional array, and we access each one of those each one of those array using J, and each one of those things is just a one array of size 3. I don't know if that makes sense, but but this is how you do multiple dimensional arrays using pointers, right? If you don't want to use pointer, then it's easy. You just do it like that, right? That's easy. But if you want to use pointers, this is what it looks like. So whenever you see 3 stars B or 3 stars array or something, whenever you see the 3 stars, then you know it might be a 2 or 3 dimensional. Well, if you see 3 stars, it might be 3-dimensional arrays, right? If you see 2 stars, it might be 2-dimensional arrays. So now what's the advantage of this, right? Well, obviously, having pointers, you can pass it around in your functions, and it will all refer to the same thing, right? So, for example, I can create a function So let's delete all the three-dimensional array stuff. Let's go back to the two-dimensional array. And for example, I can create array like this, void increment, and then I can create array like this. Well, I probably need the size, row, column, right? Probably need the size like that. Int for int I equals 0, I smaller than row, I plus plus. And for int j equals 0, j smaller than column, j plus plus. And then, so in here, in this for loops, I want to do a, I, j, plus plus. Just like that. We just increment each numbers. So if I put increment here, hey, like that, well, we know because we passed in a reference, right? We passed in a reference. So now whatever happens inside the function gonna affect the outside function, right? So before we saw 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. So now we expect to see 1, 1, 1, 1, 2, 2, 2, 2, and 3, 3, 3, 3. Right. So let's check it out. Really hope I don't make any syntax error. Oh, I knew it. Did I increment? Oh, I forgot the row and column. Increment a row column. There we go. Let's run it. There we go. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3 instead of 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. Right. So that's one benefit of using pointers is you can pass around functions and you don't have to return anything. It automatically remembers any modification you made to it. Right. So that's one benefit. The other benefit is there is actually nothing that stops me from declaring something different for each row. What do I mean by that? This is what I mean. So let's change this. So this is the two-dimensional array declaration part. Right. Let me comment out all the code below, and then I will uncomment it later on. So let's focus on this several lines of code. Right. So here we declare row column, we create a two-dimensional array here, and then we specify each row what looks like, right? What each row looks like. Well, there's nothing prevent me to say, you know what? Column is not going to be a fixed number, right? Because now each row is a separate entity now. This is not a two-dimensional array together. You have you have a array of arrays, and then each of the array can be different, right? So for example, we can do new int row plus 1. We can do it like that. So what does that do? That actually creates a pyramid, right? Or triangle, not really pyramid, a triangle, right? Because first row is 0. So your first row in your two-dimensional array gonna have only one column, and then the second row in your two-dimensional array gonna have two columns, right? And the third row gonna have three columns. So, well, no, not row plus 1 is I plus 1, right? So AI equals new int I plus 1 because I goes from 0, 1, 2. Now I goes from 0, 1, 2. Each one of your row length gonna go from 1, 2, 3. So it's gonna create like a triangle kind of thing, right? So let's modify the code below a little bit. Let's forget about increment for now because column no longer exists. So we probably wanna do j smaller than I plus 1, right? And then aij equals to I, that's fine. And then let's change this to I plus 1. Let's see if this works. There we go. there we go. So it is a triangle shape, 0, 1, 2. Right? So you have, by having this representation of pointers to pointers, pointers of pointers, pointer of pointers, right? You have one pointer that points to an array of pointers, and each one of those pointer points to a array, right? So it's a pointer to pointers. When you represent two-dimensional array like that, your row can be a little bit more flexible, like this. It doesn't have to be a fixed sized row. Well, it doesn't have to be fixed size column. Your row has to be fixed, right? Your row is 3. That's set. But your number of column can change on different row. So you have a little bit more flexibility like that. So this is how C++ represent two-dimensional arrays. I mean, sometimes you will see some function that does this, right? When you see it like that, you should immediately think, oh, that's probably a two-dimensional array. If you see a function argument like that, oh, it's probably a three-dimensional array, right? So even though it's very confusing, but just think of like this way. You have a pointer, right? Even though you cannot put parentheses on there, but this is what you should look at. You have pointer to an array of pointers, right? You have this pointer to pointers, which is 3 of the integer pointers, right? And then each one of the integer pointer is a array, just like that. So that's how you should look at it. Although you really shouldn't have the parentheses around everything. All right, so that is two-dimensional arrays. Now let's look at vectors. So vector is basically just array list. So in order to use vector, you have to go all the way to the top of your file, and then you do include vector, like that. So let's delete everything, right? Let's start from a fresh page. Okay, all right, there we go. So vector is like array list. It's basically a array of indeterminate size. So you can add to it, you can delete it, you can do anything with it, right? It has a little bit different syntax than the Java array list, obviously, but it's pretty similar. Right? So this is how you create a vector. Vector int, see it's the same, a, like that. Actually, you don't need the parentheses. The parentheses is just the constructor for it. So you can see this is basically the Java generic class. Although if you didn't take 225, you probably don't know what generic class is. But basically this is saying, okay, this is a vector of type int. Also notice different from Java is that you can have primitive type in here. Java array list, you cannot, right? Java array list, you cannot have int in there. You have to have integer in there, right? Now C++ doesn't care about that. C++, because of its flexibility, you can put a int in there. So now we can add things to it, right? So we can do, let's add 10 numbers to it for int I equals 0, I smaller than 10, I plus plus, a dot push back. So this is kind of like append, push back I. And then let's print it out. I equals 0, I smaller than a dot size, I plus plus. Cout a dot at I. So instead of add, like array list, you do push back. You append by calling the pushback function. And then instead of get, you say the at I. And the size is the same. It's all a dot size, right? It's all dot size. So let's run this, save, exit. We want to do compile. Oh, there's some problem. Vector was not declared. Oh, sorry. Lowercase v. Lowercase v. All right, let's save, quit. Non-class type. A dot pushback with this function declaration. All right. You know what? Let's not have this. I don't think that will fix everything. That fixed everything. All right. So don't put parentheses back there. Don't put parentheses back there. It's a little bit different, right? Don't put parentheses back there. Just do vector int a, and then compile, and then let's run. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So exactly works like array list. And let's see. Quickly search C++ random number generator, because it might be useful. Basically, you just need a rand. Okay. So what I'm worried about is what. So we need to do. We can use rand, or we can use srand. Which one is better? Okay, so srand is a C++ function. Okay, cstd lib. I think that's what we have to include. I don't think I can. I think I have to do the include thing. Yeah. So let's do include C. What was it? cstd lib. And then let's just do rand parentheses. Actually, I might have to change this to a double, because I think rand is just between 0 and 1. Yeah, there we go. Rand is just between 0 and 1. Actually, is it? Those number looks pretty big. Rand function to get value from range 0 to n minus 1. Interesting. Okay, so rand just gives a random integer. It's actually not even between 0 and 1. It's just some random integer. So rand just gives you random integer. That's why what you saw is those really big numbers. And then if you want a range between them, you want to do mod 10. So that will give you between 0 and 9. There we go. So that's how you want to do it. You want to do rand. So, well, of course, you have to include cstd lib, and then you do rand mod 10. So that gives you number from 0 to 9. So this is how to do random number in C++. So we create 10 random number, and then we push back, right? We append to the vectors. And then you might wonder, okay, what if I want to change a number? Well, that is also simple. So if you want to change a number, this is what you do. You do a dot at I equals to, let's say 99. Save, quit, compile. Oh, I is not declared. Sorry. Let's say a at 5 equal to, right? Because this is no longer in the for loop. Compile, run. Yeah, so that's 99 there. So the difference between this and Java is that here you just do a dot at 5 equals to 99, but Java you have to do set 99 at index I or something like that, right? So Java, if you want to change a value, you have to do set. But for vector in C++, you don't have to do it. You can just do a dot at 5 or any index equals to the value you need. Yeah, so that is vector. What else should we do about vector? It's probably remove, right? We can do remove. Although let me double check the index. C++ vector remove. Erase. So instead of remove, it's erase. So basically, you just erase some element, right? Yeah. So instead of at 5, if I just say a dot erase 5, let's see what happens. I should probably not do the random number anymore because we actually want to see that number disappearing. There. Whoa! No matching function for call. Erase int. Wait, we're not supposed to do int. Oh, we have to do the begin. Okay. We cannot do int. All right, so this is a little bit weird. So if you want to erase something, you have to do this. A dot begin, parentheses, plus 5. You have to do that. Run. Yeah, so 0, 1, 2, 3, 4, 5 is gone. 6, 7, 8, 9. So this is what you have to do. A dot begin plus 5. So this is how you erase. Apparently, you cannot just give a integer 5 in there. If you want to erase the first number, you just do a dot begin, right? That will get rid of the first number, so we should see 0 goes away. And then, of course, if you want to do the last number, you can probably, if it has a begin, probably has an end, right? Let's try it out. Oh, minus 1, minus 1. A dot end, minus 1. Man, I was really mad, right? Assertion, old top equal to initial top, blah, 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 failed. Aborted, core dumped. Oh my gosh, it sounds so serious. But really, it was because it should be n minus 1. There we go. So 0 to 8 now. Yeah, core dumped, dude. You got core dumped. That's funny. Yeah, sometimes the C++ error message can be pretty cryptic. So we can do append, right? We can do erase. We can change a value within the vector. So that's about all the things that usually you want to do. Apparently, you can also erase a bunch of things. So you can do a dot begin, begin, comma, a dot begin plus 5. So let's do plus 2. So this erase between the third element and the sixth element. So everything between 2 and 5 should be gone, including 2 and 5. Let's try that. Nope. Oh, I forgot parentheses. Put the parentheses in here. Quit. Compile. Go. Yeah. 0, 1. Oh, okay. 5 is still there. Okay. 5 is still there. Um, but 2 and so 2 to 4 are all gone. Right? So this is delete, and then you can delete a bunch of things. So again, this is very similar to array list, and then of course this is the non-pointer version, right? You can do the pointer version. Like this. And then what we have to change is instead of a dot, we do the arrow like that. A arrow size, a arrow at, and everything else should be the same. Let's compile. Yeah. So this is the pointer version of this. Okay. Now, how do you do two-dimensional array using vectors? Huh? Yeah? Think about it. All right. So if two-dimensional array using pointers look like this, right? So it's basically pointer of pointers. A two-dimensional vector is going to be, so you're going to have a outer vector that is a array list of vectors, right? So it looks something like this. So let's say if we want to do a two-dimensional double vector, this is what it looked like. Let me erase everything. So this is what it looked like. Star. And now it looks very weird. Star. So you have a vector, pointer A equals to new vector. Now what does this vector hold? This vector hold pointers to double vector, a vector of doubles. That's what it means. So you have a vector, pointer, so A points to a vector. But what type of vector is that? That A is pointing to the vector of type pointers of vector of doubles. So if you want to insert 1, 1, 1, 2, 2, 2, 3, 3, 3 into your two-dimensional vector, what do? This is what you do. Do 4, I equals 0, I smaller than 3, I plus plus, right? And then, so this is each row. So each row you have a vector double temp equals new vector double. So this is each row is just in one vector. And then you do the column. Right? So then you append those numbers, push back, you push those numbers back onto your array. Well, I probably should do I plus 1, right? Because it's not 0, 0, 0, 1, 1, 1, 2, 2, 2. It's 1, 1, 1, 2, 2, 2, 3, 3, 3. And then after we finish the row, we do a push back temp, like that. So we can print this out like this. For int I equals 0, I smaller than a size I plus plus. For int j equals 0, j smaller than a at I size j plus plus. Right? So let's see what's going on. So a size, that's the row number. A at I give you each row. Each row size, that's column number. Right? So we can do Cout A at I at J. Cout and L. So what is at I at J? So C at I, again, that gives you the row vector. And then for the row vector, we're looking at column J, so that will give us the specific number, right? So let's run, compile, run. Yeah, that gives 1, 1, 1, 2, 2, 2, 3, 3, 3. And now if you want to do the pyramid thing or the triangle thing, right? So we just need to change here, I plus 1. That's all we have to do, right? So this will give us the triangle, but we don't have to change here because we get the column size dynamically for each row. So there's nothing we have to do there. Let's compile. There, 1, 1, 1, 2, 2, 3, 3, 3. Okay. So now let's do a full example of using two-dimensional vectors. Let's do matrix multiplication, right? Well, or more specifically is matrix multiply with a vector. So we're going to use a lot of those when we're doing circuits analysis, right? So let's say we have a matrix. Let's say we read from some file, right? So some file, we have a matrix like this. Right? We have a matrix like this, and then we're multiplying that with a vector. Well, this should be n up there. And then the vector also is going to be n1 equals to, so the vector is going to look like 5, 6, 7. Right? Let's just say, yeah, let's have a smaller number, 1, 2, 3. Why not? Let's do 1, 2, 3, so that we can actually check our work. Or 3 to 1. 3, 2, 1. Here we go. Instead of 1, 2, 3, we do 3 to 1. I don't think it's going to matter, but so let's say we read from some file like this, right? Let's say this is inside a file. I don't want to do file read because I know some people wasn't able to get the virtual machine ready. So if you're using some online IDE, you might not be able to read the file. So I'm not gonna do file read. Also, I think when we are working our Arduino, I don't think we can do a lot of file read, right? I'm not sure. We'll see. But assuming that this is in the file, right? So now we read from the file. So why do we want vectors when we read from the file? Because we don't know exactly the size, right? So here, even though, yes, the size is here, but hypothetically speaking, if you did read this from the file, it's going to be a hard time for you to figure out the size, right? As you parse through each tokens, and then you have to remember the size and things like that. Well, that's why we don't have to do it if we have vectors. So vector int star, let's say this is matrix A equals new vector int star parentheses. So that's vector A. Did I have something mismatched? Like I have something mismatched. No? Weird. Oh, I forgot semicolon there. That's why. There we go. Okay, that indentation is correct. And then, so we need to copy over the matrix, right? Now we do vector, or not vector A. Wait, actually, no. We need to do this. We need to do vector int temp equals new vector int. And then we do temp push back matrix ij. And then we do A push back, right? And then for vector, for the B, or for the thing that we're trying to multiply with, let's just do one dimensional here. Star B equals new vector int, like that. And for int I equals 0, I smaller than n, I plus plus, we can just do B push back. This is going to be vec I 0, right? So we got the matrix in our two-dimensional vectors, and then we got the one-dimensional thing that we're multiplying. So we're multiplying 1, 1, 1, 2, 2, 2, 3, 3, 3 with 3 to 1. That's what we're doing, right? So if you remember how matrix multiplication works, you multiply, it works like this. So for int I equals 0, I smaller than a size, so we have row. Actually, instead of I, let me make it more clear. Row equals to 0, row smaller than a size, row plus plus. And then we need to sum up each row. So let's do int sum equals 0, right? And then we do for int column equals 0, column smaller than a at row size. Column plus plus. So then we do sum plus equals to a at row at column multiply with b at column, right? Because it's going to be it's 1 times 3 plus 1 times 2 plus 1 times 1. That's the first number. The second number is 2 times 3 plus 2 times 2 plus 2 times 1, right? So this is actually the column number. This is actually looking like that. And then we need to record this. How do we record this? Let's create a new vector called result. We don't need pointers for this. Let's just do this. Result dot pushback sum, right? And let's print it out for int I equals 0, I smaller than result size, I plus plus, cout result at I like this. So notice result is dot, right? Because result is not a pointer, right? Whereas everything before it was pointers, right? That's a pointer, that's a pointer. That's why we're using the arrow here. But down here, the result is not a pointer. Result is just a vector. All right, let's see if this works. I'm hoping that this works. Here we go. So 6, 12, 18. So it's, yeah, so it's 1 times 2 times 3 1 times 2 plus 1 times 1 times 1 times 1 plus 1 times 2 plus 1 times 3 is 6. 2 times, well, actually, no, 3 to 1. So 1 times 3 plus 1 times 2 plus 1 times 1 is 6. 2 times 3 plus 2 times 1, no, plus 2 times 2 plus 2 times 1 is 12. Yeah. Yeah. So, ooh, so yeah. So 1 times 3 plus 1 times 2 plus 1 times 1 is 6. 2 times 3 plus 2 times 2 plus 2 times 1. So 2 times 3, 6 plus 4 plus 2 is 12. Yeah, so that's correct. Right, so this is the two-dimensional vectors. And you will be using this. You're probably going to need this for project 1. So make sure you understand all of this stuff. All right, see you next time.